In this session, we are going to talk about the geometric series. Let me give you an example before the definition of it. You will remember this type of series from physics classes. 1 over 2 to the n. This is the series actually I showed you at the beginning of the series classes, right? So, and then we saw the convergency and then the sum of this series, right? When we deal with the sum of partial sequences. This type of series will be called the geometric series, but today we're going to improve a general technique about finding the sum of this type of series. As you see, in the general term of geometric series, you need to have a number, right, here, which we are going to call r, and then you need to have the power in that series. That's why the general definition should include that type of number, but you may always multiply by another constant number. Here we have a hidden one, that's gonna be my number a here, but I'm gonna always have the power of it, power of the other number, a times r squared, right? I can continue in this way up to the right infinite. So in somewhere I need to see my general term and look at that. I can formalize this sum, a times r to the n minus 1. This is my general term, as you know. General term. Okay, so from now on, I'm going to call this type of series as geometric series. Here the number a and r, right, are the real numbers. And then they are fixed numbers. So a and r are real fixed numbers. Also, a cannot be 0 otherwise, right? I wouldn't have that type of series. But sometimes I can see this series, okay, in that form. Since when we solve some kind of problem, that point is going to be important. Look at that. Instead of starting the index by 1, I may want to start the index by 0. If that's the case, right, I can reduce the power by 1. So look at that. These two expressions are going to be same. So please don't forget this point, since we are going to use this point, okay, in the next examples. Okay, what is my problem? My problem is this one. When you are given a geometric series, a times r negative 1 and n minus 1, is this a convergent series? If it is a convergent, right, what is the sum? Basically, these two are my essential question I always ask about the series. What do I know about the convergence of the series? I just know the sequence of partial sum, right? So, sequence of partial sum. And then we talk about, right? We said that this is the best technique, but this is the most difficult technique to be able to use. But I'm gonna try it, okay, to see if my geometric series is convergent or not. What I want to do, I want to create, right, the sequence of partial sum this way: a plus a times r plus a r squared, and up to the, look at that, the first n term sum. So my n term is going to be this one, right, n minus 1. In the next step, since I need to find out the limit of this, and look at it, I cannot take the limit of this sum. That's why I need to do some algebraic operation, so that I can find out the limit of this partial sum. What am I gonna do? I will use some algebraic technique. I will multiply my partial sum by r. If I multiply by r, so I'm just multiplying the first line by r times a plus AR squared plus A times R cubed plus, so last term is going to be equal AR times N. Since if I multiply by R, -1 will cancel by plus. And I'm going to subtract the second term from the first one. That's why I need to multiply the second term by negative. So if I'm going to subtract, look at that, all the terms I have here is going to be negative, correct? So now I can add them. If I add them, look at that, this term will cancel by this term will cancel by this term, and then all the terms, right, will go away, except my last term, right, and my first term. On the left-hand side, what I have left, Sn minus R Sn, which is equal A minus A times Rn. Okay. I was trying to formalize what the Sn in a better way. So Sn is going to be equal then A minus A times R to the N, or look at that, 1 minus R. I can do better, right? Sn can be written in this way. So A is a common term, right, on the top, 1 minus R to the N, and then over, look at that, 1 minus R. Okay, I get a new form of Sn. To be able to find the convergence of my geometric series, as you know, I need to find out the limit of this, right? So the question will turn into, right, what is the limit of sequence of partial sum? So A times 1 minus R to the N, 1 minus R. Look at that. So my series question turned out, right, as limit of sequence question. That's why we learned a lot of things, right, about the convergence of the sequences before we start the series discussion, guys. Do you remember, right, how could I take the limit of this question? The only term here, look at that, I need to find out is this term. So all the other terms, as you see, right, that they are all constant. So if I can cancel this one, right, I'm going to be able to find the limit of the partial sum of sequences, and then that's going to be equal to what? That's going to be equal to sum of the series. I know from, right, the first part of my discussion about series. Limit of the partial of the sequence is going to be equal to the sum of the series, guys. So this is going to be 0. You remember, guys? When? If you remember that the commonly used limits about the sequences, if R is less than 1, right? If R is a number less than, which is less than 1, then I know, right, this guy is going to go 0. And then look at that. At the end of the day, I can write it down, this formula, right? Perfect. I have now a formula for the sum of the geometric series. Look at that. I can summarize in this way. N is equal 1 up to the infinite. A times R n minus 1 is going to be equal, right? It's going to be equal to this number, A over 1 minus R, when the R is going to be less than 1. But if R is not less than 1, if it is equal to 1 or is bigger than 1, so what will happen? This will go infinite, right? It is not convergent. If this is the case, so you can say this one, it is divergent, right? And then you can just shortly say it is convergent. Perfectly fine, right? So now I have a nice formula about my geometric series, guys. From now on, I'm just gonna use, right, this formula when I have an example, when I have a question about the geometric series, guys. Geometric series. Okay, it is time to solve examples, right? That's the end of the discussion, and then I derive my formula for the geometric series. Now I'm gonna solve a couple examples for you. Okay, first example, let's try to apply the formula directly when I don't have any problem, any issue with the given examples. Look at this example, guys. N is equal 1 to the infinite 3 times 1 over 2 to the n minus 1. So first of all, guys, you always need to look for this form, okay? That's so important. You are going to understand from the examples why it is so important. N is equal 1 to the infinite. So you see, that is my, my essential form for the geometric series. What do I mean by that? N should start by 1, and then I should have the n minus 1 on the top of R. If you don't have this, you cannot use, the formula I put in the red box. But if you have this formula exactly, if you have this form, you are free to use the formula I put in the red box. Look at that. Do I have the same form in my example? Yes. Why? Look at that. What is my A? You need to determine what your A is and then what your R is. This is my A, right? As in the original form. And then do I have my R? Yes, this is my R, as you see. And then look at that. I have here the n minus 1, and then the index starts by 1. That is why, right? I can use the formula in the red box directly without doing any operation before that. But later you are going to see I need to do something, right, to get the original form. That's why I can use my formula. Formula says you can just use the A. A is equal to 3. And then look at that, over 1 minus R. R is equal 1 over 2, right? That's the formula when. Did I forget something? I forgot something. I need to check out, right, if the R is less than 1. Fortunately, right, I have an R, right, which is less than 1. That's why, right, I can use this formula without problem. So my formula, after applying the formula, look at this is going to be my number. If I, right, use this formula, the result is going to be just 6, guys. Did you see that? So it is so easy if you satisfy the conditions about the geometric series, and then I found the sum of infinite to many numbers. Okay, another example. This is another example. N is equal 1 to the infinite, negative 1 to the n, 5 over 4 to the n. So look at that, guys. So again, your first job is to follow the original form. Do I have it, right? Do I have the original form? What the original form says. Your index should start by 1. Yes, that's good, right? And then, sorry, that should be negative 1 for now, since we are gonna change later, okay? And then do I have the n minus 1 on the top of, right? Look at that, on the top of my numbers. Yes, I have. Okay, what is A then? A is, as you see, right, A is here 5, since that number, right, doesn't have any power. So A is this number. Okay, what about the R? As you see, I have 2 numbers here, but I know I can combine this number in this way, if you remember, right, from the power number feature. So it can be written in this way, guys, right? So you need to use sometimes algebra to get the original form. I'll look at that now. I can write this one 5 times negative 1 over 4, right, n minus 1. So now my A is going to be equal 5, and then my R is going to be equal negative 1 over 4. Is it less than 1? Absolutely, right? And then 5 is equal A. So I can use my formula. Formula says 5 over A over, right, 1 minus R. What is R? It is equal negative 1 over 4. Okay, 5 over 1 plus 1 over 4, right? If I calculate this, it is going to be equal just 4, as you see, right? Another example. But these examples are going to be a little bit differences. We're going to do a couple of other things right before the formula. Look at this example. It is similar to the previous example, but it is also different. 4 to the n plus 2. Okay, what is my original form? My original form is this one, right? Without original form, I can't use my formula, which was in the red box. The original form, right, requires us, I need to have the power on the top of r. The power should be exact n minus 1. I look at that here, right, I don't have that power. So n minus 1 I should have, but instead of n minus 1, I have n plus 2. Okay, your problem here, you need to think about how could I write n plus 2, right, which is equal to n minus 1. Is there any way? Yes, look at it. This is just arithmetic problem, guys. Can I write this n plus 2, which is equal n minus 1 plus 3? Perfect, right? So now, if there is a way, find writing the n plus 2 as n minus 1, I can use it. I can use in this way. Now look at that. And then I can use, right, the power numbers feature in this way. And I can separate, right, these two numbers. Look at that. n plus 2 can be written n minus 1 plus 3, and then I can separate them in the bottom. Okay, guys. Now, I have this formula. I wrote it down. And then you need to be able to tell now who is A. Look at that. This is my new A, right? And then I have the R here. R is going to be equal 1 over 4. Of course, it is less than 1 in this case. So I can use my formula, right? I'm ready to use my formula. So my formula will say A over, which is 5 over 4 cubed, and then 1 minus 1 over 4, right? If you calculate this one, I think it is going to be equal 3 times 4 squared. Okay, so it is equal 5 over 48, if I'm not wrong. Another example. One more, like this one. N starts again by 1, infinite, and look at that. 2 over 3 to the n minus 4. As you see, we have this similar problem here, right? I was expecting to have the n minus 1, but instead of n minus 1, I have the n minus 4. Can you please tell me how could you write this term, right, in terms of n minus 1? So n minus 1 minus 3, as you see. So now, my series will turn into 2 over 3 to the n minus 1 times 3 to the negative 3. So from here, look at that. This is going to be my number A, right? This is my A. And then my number R is going to be equal 1 over 3, which is less than 1. That is why I can use the formula in the red box, right? Since R is less than 1. And then I have the form I need. So 2 over 3 to the negative 3, or 1 minus 1 over 3. Okay, guys, just calculate what it is. The last problem is going to be totally different than what we solved. I told you right at the beginning, look at that, guys. This form, right, that's the form I always use to solve the geometric series question. This form is equal to this form. A R to the n. Look at that. the difference between, right, these two index, right, their index are different, and also the powers are different than each other, but they are same, right? If you expand them, right, you're gonna see they will give you exactly this one, guys, okay? So they will exactly give you this one, a plus ar plus ar squared, and exactly same thing you will obtain. And then look at that. So instead of starting by 1, if I had an example, look at this, starting by 0, what I would do, like in this example, n is equal 0 to the infinite, 2 over 3 to the n plus 1. Look at that. So since my index starts by 0, look at that, instead of using the first form, right, this is the first form, I need to use the second form. Look at that. If I start by if I start the index by 0, I need to use this form. But I told you, right, they are same. That is why if I have an index start by 0, my power, right, should be n instead of n minus 1. Okay, I'm going to use the same trick, right, I did in previous example. Can I write the n plus 1 in terms of, right, n plus something minus something? Yes, look at it, n plus 1, right? So this will turn into this one. N is equal 0 to the infinite, 2 over, right, the 3 to the n times 3. My index starts by 0, and then my power, right, is n. So look at that. I have the form, right, that I need. So if they're same, of course, I can use the same formula, right? So if the r is less than 1, of course, I can use the formula, right, to calculate the series. But if the r is not less than 1, that's going to be infinite. Here, my a is going to be equal this number, and then my r is going to be equal 1 over 3, right, which is less than 1. So I can calculate in this way, 2 over 3 over 1 minus 1 over 3, right, which is going to be equal 1. Did you see that? My result is going to be at the end of the day, but I used, right, a different form to calculate the same geometric series. Okay, that's all for today, guys. See you in the next session.